All right, in this episode, we are going to look at solving a systems of equations using elimination. To do so, I would have two equations. I want to ensure that they are lined up according to their variables, as well as any constant. I am then going to add or subtract these depending on what is going to make one of these variables cancel. If I were to decide to use addition, notice then I would have 3 plus 3, which is 6y. That is not going to cancel. And adding minus 5 to minus 10 is also not going to cancel that because that would turn into negative 15. So I know that what I should be doing is subtracting. If I were to have minus 5 and subtract a negative 10, remember when you subtract a negative number, that actually turns into addition. So this is going to become 5x. 3y minus 3y is 0, so those y's are going to cancel each other out. On the right-hand side of the equation, we have minus 1. Remember, we are still subtracting. So minus 1 minus 19 more is minus 20. Now what we have here is a one-step equation. If you've forgotten how to solve for 1 and 2 steps equation, you can refer to another tutorial in the link below. Now, to get x by itself, I need to divide. Since 5 and x are being multiplied together, the inverse is to divide both sides by 5 so that those cancel. And we are left with our answer of x equaling negative 4. Now, we're not done here. What we have done is we have solved for x. That is the first part of the solution. The x value in our solution is negative 4. What we need to know is our y value for our ordered pair. So I am going to take this minus 4 and I am going to substitute it back into either the first equation or the second equation. It doesn't matter which one. I'll choose to put it in the first one. So I have minus 5, x is now negative 4, plus 3y equals negative 1. We are going to need to solve for y, so the first thing we are multiplying is minus 5 times minus 4. A negative times a negative does turn into a positive. Now the next step to get y by itself is to move the 20. In order to move the 20 to the other side, I need to get this to 0, and the way to do that is to subtract 20 from both sides. Now I have 3y equals minus 1 minus 20 more is negative 21. And just like previously, the last step is to divide by whatever is attached to y. So once again, we're going to divide by 3 this time so that those 3's cancel. And now my y equals negative 7. So there is my solution set, minus 4 and minus 7. Let's try another one. All right, so first thing you need to decide is should you be adding or subtracting these two equations to make one of the variables cancel? Now I can choose here. If I choose to add, I can make these x's cancel. But if I chose to subtract, I could make the y's cancel. Since I've already written addition, I will stick with that. Minus 6 plus 6, I don't have any x's anymore. 2 plus 2, I have now 4 y's. 10 plus minus 14 is a negative 4. And now I would have to divide both sides by 4, and that leaves me with an answer of y equals negative 1. What we found, again, in our solution for our ordered pair now is the y value first this time. So now I need to take this y value and put it back into either equation 1 or equation 2. You can decide. I'm going to go with equation 2 this time. Now we will have 6x plus 2 times y, and y, our answer was negative 1, equals negative 14. 2 times negative 1 is negative 2. And now I have a two-step equation. The first step would be to move this minus 2 by adding 2. That will cancel this out, leaving me 6x equals negative 12. Last step of my two-step is to divide by 6 so that I can get x by itself. And so x equals -2. Now we have found the x value in our ordered pair of our solution. So far, we have not had to find an equivalent equation because we were able just to add or subtract and make one of those variables cancel. In this example, none of these leading coefficients will cancel each other, so I'm going to have to change one of these equations. I am going to choose to change the 3x because I cannot make 2 and 3 the same number easily without changing both equations, which we'll see in a later question. If I was to multiply this entire equation by 3, then now I have a new equation of 3 times 3, which is 9x minus 9y equals, what's 18 times 3? Well, that's 54. So we're going to have minus 54 on this side. I'm going to just rewrite this original equation that we had over here. I don't need to change it at this time so that I can line them up. All right, let's go through and decide. Do I need to add or subtract to make these 9's in front of the x's cancel? The x's is what I am going to cancel because they have the same leading coefficient. Well, I would need to add because minus 9 plus 9 is 0, and now those x's are gone. Let's continue. 2 adding -9 to it puts us at -7y. 5 adding -54 to it makes a total of -49. Now, when I divide, I want to make sure that I divide not only by 7, but by that negative that's attached because I want a positive value for y. So y equals, dividing a negative by a negative number makes a positive. All right, in our solution set, we have found the y value. So again, I'm going to take this y value now, and I can choose. I can put it in this first equation, I can put it in the second equation, or I could choose to put it in my third equation that is equivalent. I think I'm just going to go ahead and put it in the first equation. So we have minus 9x plus 2 times y, and y is now 7, all equaling 5. Therefore, minus 9x, 2 times 7 makes 14. And now I have a two-step equation to solve. The first step to get x by itself is to move the 14. Since I have a plus 14, I will get to 0 by subtracting 14. And now I have minus 9x equals 5 minus 14 is -9. Last step of our two-step is to divide by the number attached to x, including the symbol, which is -9. So finally, x equals 1. Anything divided by itself is always 1. And there is our solution set. Let's try one more like that. Once again, we notice I do not have the same leading coefficient in front of the x's or the y's. So I can change one of these. I can't make a 4 become a 2. Well, actually I could. I could divide both sides by 2. I'm going to choose to multiply the first one by 3. If I was to multiply this by 2, this entire equation by 2, that will become 4x plus 12y equals -24. I don't need to change the second equation because I have a 4x already. And that equals 16. We're ready to line them up. Now, what do you think? Should I add or subtract? What's going to make those 4x's cancel? It should be subtracting, because if I add, I end up with 8x. So let's subtract. 4 minus 4 is 0. Those x's are gone. 12y minus 4y is 8y. Minus 24 minus 16 more is -40. Now I need to get rid of this 8 And I do that by the inverse of that multiplication, and that is to divide. So now I have my answer of, well, how many times can 8 go into 40? That's 5 times. So the answer is -5. Now we have our y value for our solution set. Once again, let's take that y value and let's put it into either equation 1, equation 2, or my equivalent equation. It makes no difference. I'm going to go with equation 2. I'm going to put it into this 4x plus 4y. So 4x plus 4y, and y is now -5, is equal to 16. 4 times -5 is -20. Now I have a two-step equation. First step is to add 20 to both sides. Again, if you've forgotten how to solve a two-step equation, please refer to one of my other videos. 16 plus 20 is 36, and the last step to get x by itself is to divide by that 4 that is attached. 36 divided by 4 is 9, and there is our answer. Now, we have gone from not having to change any equation to changing one equation. This last example, I'm going to need to change both, because there's no way to make a 7 a 5 or a 5 a 7 or a 7 a 3 or a 3 a 7, so they both need to change. And here's where you get to decide, what are you going to cancel, the x variables or the y variables? I'm going to choose to cancel the x variables. So what is the common factor between 7 and 5? Well, we can simply multiply these together, which is 35. So I'm going to make each of these 35. The way to do that is to change this first equation by multiplying by 5. The way to change the second equation then is to multiply by 7. I'm just switching them around. So let's find two new equations. 5 times -7, there's the -35x. 5 times -7 again is -35y. And 5 times the -7 on the right-hand side is another -35. Now on the second equation, we're multiplying everything by 7. So I have -35x again. 7 times -3 is -21. And 17 times 7, that's a bit bigger of a number, that is going to be -119. I've got two new equations we can line up. We have the same leading coefficient. How am I going to make these x's cancel? If I chose to subtract, remember, subtracting a negative number is what is going to make this addition, which is what I need to do, because I need -35 to be +35 to make 0. So we are going to subtract. So now if we do the same thing, I've got 35 and I'm -35. Subtracting a -21 turns that into +21. So I am left with -14y. -35, subtracting a negative, is going to turn that once again into adding 119. And so that becomes a total of +84. Last but not least, we want to divide by -14 to get y by itself. And that's going to give us a negative number, because a positive divided by a negative always gives you a negative. All right, to our solution of our ordered pair, we have a y that is -6. I can choose to take this -6 and put it into the y in the first equation, the second equation, our third equivalent equation, or our fourth equivalent equation. It does not matter. I'm going to choose to put it into the first equation. So we have -7x minus 7 times y, which is now -6, all equaling -7. Let's do the multiplication. What is -7 times -6? Well, a negative times a negative turns into a positive. and that is 42. Once again, we are left with our two-step equation, where the first step is to subtract 42 from both sides. That will cancel that out, leaving us with minus 7x. Minus 7 minus 42 more is a negative 49. And you can already see the last step. Divide both sides by what is attached to x. And so we get an answer of 7. So there is our solution set for this last one. So be careful. You might have to change one equation, both equations, or maybe none at all. If you found this video helpful, please remember to like and subscribe, leave your comments below, and happy mathing.